Okay, there you go. We're recording now. Good morning again, everybody. So today we'll be tackling the last section. Alam ko na ngayon, last section na ng chapter chapter 3. So basically it's about chapter 3, section 7. Will be all about inverse differential operators. Now, when I was reading, nung nagpe-prepare ako kaninang umaga, pagkagising ko, before mag-math 174, binrowse ko kung ano yung materials for today for math 151. And kanina ko lang nakita, wala palang PowerPoint slides na available sa akin dun sa files na shinare sa akin. Though, meron lang isang video that is a recording of the discussion of the topic. So naghanap pa ako sa Google Drive and so on. Talaga nagpanic ako kaninang umaga before mag 174. So naghanap ako sa Google Drive and I saw a PDF printout of the slides that they used. And it's I don't want to disturb my other colleagues who taught this last semester at manghingi ng PowerPoint slides. So ginawa ko, dinownload ko na lang yung PDF printout and then I uploaded it dun sa ating Canvas. And while browsing through it, it's a blessing, the silver lining in not having the PowerPoint slides ay hindi ako comfortable dun sa notations na ginamit nila. So I decided dahil wala na akong time to prepare a different set of PowerPoint presentations or slides or type settings in LaTeX or in PowerPoint, I decided I'll give a chalk and talk lecture for today. Chalk and talk in quotation marks. But basically, the examples, the ideas that I'll present is the one uploaded in Canvas section 3.7. Meron lang konting typos dun sa slides na yun. I cannot edit because it's already in PDF. And I'm really not comfortable with how they denoted things. So kaya, eto yung notations na gamitin natin. But I will understand if in your pre-final exam, you'll use the notations in the slide. I'll just use the more comfortable version for me. All right. So we'll try to finish those two parts of section 3.7 today so that on Friday next week, we can start talking about chapter 4. Because it turns out Wednesday next week is Bonifacio Day and it's a holiday. So meron kayong free day on, when is that? You have a free day on Wednesday. Okay. So let's start. So the idea here is still chapter 3. We're still looking for solutions to general linear differential equations. So we are still talking about finding solutions or finding the general solutions or the general solution, singular lang, the general solution to a non-homogeneous GLDE. Non-homogeneous GLDE of the form f of d equals r of x. Again, f is a polynomial, so our assumption here actually, kailangan ba polynomial si f? Yes, for this particular section, we will assume that f is a polynomial. And r, the forcing term, is not identically the zero function para maging sure tayo na non-homogeneous yung ating GLDE. Now, we know that there are two steps to it. The first bullet is to find y sub c, or the general solution y sub c. Find the general solution y sub c to the homogeneous GLDE. So you will solve f of d equals 0, all right? So zero nyo muna yung forcing term. And this is easy, especially if f is a polynomial. We'll just look at the roots of the characteristic polynomials and based on the nature of the roots, kung simple roots yan, real roots, kung siya ay repeating roots or roots of higher multiplicity, or if it's complex roots or combinations thereof, we know how to devise the function y sub c. So the first bullet should be an easy peasy task for you, at least for now. As of now, dapat madali na yan. Except possibly if f is a very high degree polynomial na mahirap solban ng roots. So to review nyo sa algebra, rational root theorem, factor theorem, and so on. So para magkaroon kayo ng idea how to find f of d. Sa mga nagmamath 175 dyan or nagmath 175, we discussed there how to solve nonlinear equations numerically. So pwedeng ganun yung kung nag-approximate lang kayo, hindi nyo makuha yung exact solution. So you can use the approximation, pero sa 175 pa natin yan madidiscuss. Which gives you an idea, siguro next sem, isasama ko to sa mga particular examples doon when we talk about nonlinear equations. So something to look forward to sa mga nag-174 dyan ngayon at mag-175 next semester. But essentially, that's the first bullet. The second bullet proves to be the more difficult one. So we want to find so yung term, kanina kasi unique yung non-homogeneous solution kasi siya yung general solution. Now we want to find a specific or a particular solution to the non-homogeneous GLDE. So let's call our GLDE equation star. So kailangan makahanap lang tayo ng isang specific na y sub p na makakasolve ng nonlinear GLDE. Once we found a particular solution, we'll just need to combine the results from the first and the second bullets to get the general solution. Y sub c plus y sub p is the general solution to equation star, meaning any solution or any function that will satisfy star, sorry, I forgot the y there, any function y that will satisfy equation star will be of the form y sub c plus y sub p, okay? Now, we have developed several ways on how to do bullet number 2, but that is very dependent on how R of x looks like. So if you can devise a homogeneous GLDE for which R is a solution, then you can use the method of undetermined coefficients. Now, if R is a constant, then you can find a particular solution y sub p by inspection. If R is you can try the method of reduction of order or the method of undetermined coefficient kung madaling isali sa integration si R. Right? Yun yung ginawa natin last meeting, but that's very heavy on integration. And there's a problem in integration, right? It's not always easy to find integrals at malas-malas na lang kapag lalong walang closed form antiderivatives yung mag-arise dun sa variation of parameters or sa reduction of order. So if you cannot integrate one of the integrals that pop up in the method of variation of parameters or reduction of order, then you have to look for other methods. And for today, we look at specific recipes again on how to solve the particular solution. But this time it involves exponential function and trigonometric functions. Although, kaya nating, let me see. Yeah, actually, kaya nating isolve yung mga examples ko today using the other methods, specifically the method of undetermined coefficients. But if you think the method of undetermined coefficients is quite heavy for you kasi marami siyang steps na ginagawa. I think there are 5 steps there. Here's an alternative approach. Though the formulation that I will discuss will apply for any form of R, pero naka-hinge kasi siya sa itsura ni F. At malaki rin yung dependence niya on how F looks like, how the operator F looks like, at ano yung relation niya dun sa right-hand side. So it's a very restrictive method, but it's very efficient. Makikita nyo, madali to. So kesa ka mag-method of undetermined coefficients, try this one first. Baka naman mas madali ito. Especially if you have exponentials and sines and cosines involved, right? And this method is called a solution via inverse differential operators. Okay. Now, the idea behind this is you want to find a particular solution, right? So essentially, in this method, we want to find WTF sana yung susulat ko. We want to find. Pero, so we want to get or we want to find y sub p, the particular solution, such that f of d applied to y sub p equals r of x, right? Ito yung gusto nating makita. Ito yung property na nasa-satisfy ng particular solution y sub p. Now, if f is invertible, if the operator f of d is invertible. Meaning, remember from Math 17, or wala na pala kayong Math 17, ano? Lumalabas tuloy yung edad ko. Pero sa inyong algebra and trigonometry, if you have a function f and you have if f is invertible, meaning there will exist a function f inverse, right? So kung meron kang function f, apply f of x, yung inverse function f inverse is the function that when applied to f, when applied to f of x, will give you back x, and also f will also be the inverse of f inverse. So kapag ka meron kang function f, yung inverse niya ay yung i-apply mo sa kanya para ma-undo yung action ni f. So f inverse will undo whatever the function f did. Kasi si f, tinransform niya si x into f of x. Now, to reverse the process or to cancel whatever f did or to undo really what it did, kailangan nating i-apply si f inverse. So f inverse of f, you're gonna get x. And the same thing goes for f and f inverse. So essentially, if we can find a way on how to compute f inverse for this particular case, then we can find y sub b by simply applying the inverse operator to both sides of this equation. So kung, and it's a big if because not all functions are invertible. Siguro sa Math 111, naalala nyo na any function, a function is invertible if and only if it is bijective o sa Math 101, right? So ang isang function ay invertible lamang kapag siya ay bijective. It's a one-to-one correspondence. Siya ay injective at saka surjective. Now, if the operator f of d is invertible, that is the inverse operator, we'll denote it by f of d, f inverse of d. Then I can just apply f inverse d, which is the inverse operator, to both sides of our equation double star, right? So we can say that double star will then become f inverse d, followed by follows f of d applied to y equals f inverse of d applied to r of x, right? So in-apply ko lang sa kaliwa ng mga expressions sa double star yung f inverse of d. Now, the composition of functions is an associative operation. So that means I can redo the grouping here. Actually, hindi pala grouping, hindi na associative property. Property na lang to ng inverses. You have here the function, the inverse of f, but you have here f. So essentially, f inverse of d will undo whatever f did. But what f did is to transform y into f of dy, right? So ibig sabihin, ito sort of makakancel na to kasi nga nire-reverse niya yung process. So the left-hand side will just be y sub b. And then the right-hand side would be f inverse d applied to r. Now, this sounds to be a very, a very simple plan, right? Pero ang problema rito, maraming ifs dito. The first if is, nag-exist ba si F inverse? Dapat mag-exist siya para mag-work itong approach natin. And then, pangalawa, dapat madaling i-apply si F inverse of D kay R of X. Right? There should be special R of X's. Now, in general, the inverse of a derivative operator is the integral operator. Kaya kung mapapansin nyo sa method of undetermined coefficients, yung f of, maraming integration na involved para makuha si y sub p. Kasi nga kung komplikado si f ay puro derivatives yung laman, so ang inverse niya malamang puro integration yung laman. So you need to integrate. So this is an integral operator. You're gonna apply it to R. So marami kang integration na pagdaraanan at yun yung malaking problema. That's the second big if that this method entails. But for today, I'll talk about specific forms for R of X na madaling kunan or madaling applyan ng F inverse of D. Actually, if F is a polynomial with constant coefficients, then we can devise certain ways on how to find the F inverse of D applied to R whenever the forcing term R is an exponential of the form e to the kx, or if it is trigonometric of the form sine of ax or cosine of bx. Yun yung titingnan natin for today. Okay? Now let's start with when R is an exponential forcing term. So probably let's have it as section A or subsection A. So when this is the case when R of x equals an exponential of the form e to the kx, where k is a real number. Okay? So kapag ka yung forcing term nyo ay exponential, ito yung sinasabi ko kanina, na pwede nyo gamitin yung method of undetermined coefficient. Way back chapter 3 point, what's its number? I think it's 3.6 part 1 or part A. So somewhere there, yun yung ina-apply natin. Yung gumagawa tayo ng GLDE, homogeneous GLDE na sinosolve ni e to the kx. Pero that's a very tedious process. That's a long one. Now, an alternative is this. We're going to use some theorems para ma-simplify yung pagkuha ng particular solution. Okay? Now, how do we do this? Well, I need to find a way on how to apply f inverse of d to the exponential function e to the kx, right? So essentially, equation starts. So in this particular case, so we have, in this case, we have, or we want to solve, we want to solve f of d applied to y, or applied to y sub b equals e to the kx. Diretso ko na, e to the kx. Alright? So ito yung gusto nating mangyari. However, I can make use of some theorems. Let's see. Gusto kong baligtarin yung process eh. Yeah. Okay, we want to solve this. But first we note, ganito ko na lang, hiwalay ko na lang. Pagdidiretsoin ko na sana. We note that from one of the theorems from section 3.4, so siguro from, hanapin ko lang yung notes ko. Hinanap ko na to kanina kung anong theorem number. Oh, from theorem 3.4.3, we have f of d applied to e to the kx. Ito ay equal kay e to the kx f of k. Okay? So ito ay I think pinrove ba natin to? I think this is one of the, hindi, in-skip yata natin yung proof nito. So, but this is theorem 3.4.3. So if f of d is applied to e to the kx, then that is equal to e to the kx times f of k. Now, k is a constant, so this means this guy will be a constant. Tapos i-evaluate mo lang yung characteristic polynomial dun sa number k, which is essentially the exponent for, or the multiplier to the exponent of our exponential function. Now, we can break this down into, oh, I can apply the inverse of f to both sides. So that means here, I can apply f inverse of d to either side of our equation to the left. Kasi I need to be careful kung saan ko siya i-apply kasi hindi commutative ang composition. But yeah, just be consistent and then you'll get this f inverse of d. So sa left ko rin siyang ang applyan ko naman ng f inverse d dun sa kanan ay si e to the kx times f of k. Good? Tapos here, I'll use the property of inverses. These two are inverses of each other. So what will be left would be e to the kx. And then this guy would be, oh, here, let's simplify the right. F of k is a constant. F inverse d is an integral operator with respect to the variable x. So si f na walang involved, si f of k, wala dyang involved na x. So ibig sabihin, f of k is really a constant with respect to this operator. So that constant can come out of that process. Okay. Magkakaroon lang ako ng f of k times f inverse d applied to e to the kx. And this is also part true because f doesn't have, or f only has constant coefficients. Okay? So ito yung meron tayo. But how do we simplify itong nasa kanan? So it's oh, actually, I don't need to simplify it. I'll just need to break it down into two cases. So case one, if f of k is not 0. Okay, because if f of k is not equal to 0, then we're done. Because if k is not equal to 0, then we can divide both sides by f of k, and then I'll flip the equation. So I'll have f inverse of d applied to e to the kx ay equal lamang kay e to the kx all over f of k, right? And this is how we compute the inverse operator the inverse operator applied to e to the kx. All right. So this is extremely helpful if r of x is e to the kx. Kasi kapag ka si right hand side ay e to the kx, pwede ako ngayon mag f inverse of d both sides, f inverse of d both sides, right? So ito maka-cancel lang yung f inverse b, so we're gonna get y sub p on the left side. Then the right side would be f inverse of d applied to e to the kx. Now, if k is not equal, if f of k is not equal to 0, then this is just e to the k of e to the kx all over f of k. That's simple. Okay. Does that process make sense to you guys? Is the derivation fine? Paramdam kayo, guys. Okay, thank you. Or napilitan lang mag-thumbs up. But I hope this is okay. Unless, or if it's not clear, ask me your questions now. Or dina-digest pa. So that's fine, but I hope you see the idea. Well, siguro to augment the mental processes you're going through right now, siguro tumingin muna tayong specific examples, paano siya ginagamit. And siguro that will that will help us make sense of the entire theoretical derivation. Okay, so let's look at the example one. So in the following examples, or in all of the examples we have today, the instruction is to find a general solution to the non-homogeneous GLDE, right? So first, say our GLDE in example one is d squared plus 1 applied to y equals e to the 3x. Okay. Now, the right-hand side is an exponential of the form e to the kx, where k is equal to 3. Okay. So I will now try to apply case number one. I'm hoping that case number one will apply because that will require f of k to be not 0. Or in our case, f of 3 should not be equal to 0. But for that, let's first let f of d to be d squared plus 1. Okay? So ano lang, notation lang. Then that means f of k, but again, our k here is 3 because k is the exponent to the exponential on the right-hand side. So we'll have f of 3. F of 3, so papalitan nyo lang lahat ng capital D by 3. So we'll have 3 squared plus 1, that's 10, not equal to 0. Yay, applicable yung case number 1. Now, how do we apply case number 1? Well, that's for the particular solution, so punta muna tayo sa first bullet. So now the characteristic to find y sub c, right? So the characteristic equation is f of m equals 0. So that means it's m squared plus 1 equal to 0. And the solutions are m equals plus or minus I, two complex roots. And from here, we can find the homogeneous solution, y sub c, as c1 cosine x plus c2 sine x. All right, so that's the homogeneous solution. Now let's find a particular solution to the non-homogeneous GLDE, right? To complete the picture. Then here we need to find, siguro full sentence ko siya gawin, to find the particular solution y sub p such that f of d applied to y sub c, y sub p, dapat daw satisfy ng non-homogeneous sorry, naputol ako, na nakaka-satisfy ng non-homogeneous GLDE. But again, ang naturo sa atin kanina, kapag si f of k ay hindi 0, alam natin kung paano i-evaluate yung f inverse applied to e to the kx. So that's what I'll do here. I'll apply f inverse d to both sides. Now, you can skip some of these steps. Specifically, pwedeng wag nyo na itong isulat itong step na to. Pero for starters, I always write this. Actually, kahit hanggang ngayon pa nagsasolve ako, sinusulat ko pa rin step by step kasi hindi ko kaya yung maraming steps na ginagawa mentally, right? So I know that f inverse d is the inverse of f of d, so they will just undo each other. So we'll be left with y sub p on the left side. And here we have f inverse of d applied to e to the 3x. We know that case 1 applies. So ibig sabihin f inverse of d applied to e to the 3x is simply e to the 3x all over f of 3, right? So that means this is e to the 3x all over f of 3. And this is valid because f of 3 is not equal to 0. So this would be e to the 3x over 10, right? So nakuha na natin yung f of 3 kanina to be equal to 10, not 0. So therefore, our general solution is y equals our y sub c plus y sub b, e to the 3x all over 10. That's it. And we got the solution in less than a page. Ano? So dati yung mga solution natin inaabot ng ilang slides. But I think this is much simpler than the method of undetermined coefficients. All good? Does the solution make sense? Ayaw nyo talagang sumagot. Thank you, John Rences, finally. Okay, yeah, thank you, Kiefer. Now let's try another one. Let's say try d squared plus 3d minus 4 equals 12e to the 2x. Okay. Now again, first I will let f of d to be equal to d squared plus 3d minus 4. And at this point, I can check if case number 2 will hold. In this particular example, k is equal to 2. Because again, k is the multiplier to x in the exponent of e. So that means we need to check f of 2. And f of 2 is 2 squared plus 6 minus 4. So that's going to be 6. Okay, which is not equal to 0. So I know that case 1 will apply, so I can proceed as what we did in the previous example. First, I'm going to find the solution to the homogeneous GLDE. So the characteristic equation is f of m equals m squared plus 3m minus 4. And we want this to be equal to 0. We can factor the left side, and this will be m plus 4 times m minus 1. Tama ba? Equal to 0. That means m equals negative 4 or positive 1. So therefore, our homogeneous solution, y sub c, is c1 e to the negative 4x plus c2 e to the x. That's it, right? And then next, dito tayo nahirapan dati sa method of undetermined coefficient or kahit sa variation of parameters, paghahanap ng particular solution. So here we are solving for y sub p such that f of d applied to y sub p will be equal to r of x. Our r of x is 12e to the 2x. Now I will apply f inverse of d to both sides. I'll skip that step. Pwede niyo rin siyang i-skip. Basta ang idea, i-apply mo si f inverse d sa parehong side ng equation. You'll be left with y sub p on the left, and you will have f inverse of d applied to 12e to the 2x on the right-hand side. But again, f inverse d is the inverse of a convoluted differential operator. So most likely it would be an integral operator of some form. But nevertheless, merong linearity property ang integrals. So that means a scalar multiplier 12 can come out of the inverse operator. Okay, so that means I can write it as 12 f inverse of d applied to e to the 2x all over. Sorry, wala pang all over. Nilabas ko lang yung constant na 12. And now, since we know that f of k, or f of 2 is not equal to 0, then we know that f inverse d applied to e to the 2x is simply e to the 2x divided by f of 2. And this is 12 times e to the 2x all over 6. So we'll be left with 2e to the 2x as a particular solution. So then we can conclude that our general solution is given by y equals c1 e to the negative 4x plus c2 e to the 2x. This is our y sub c, right? Plus, dapat i-plus ko yung y sub p. We found a particular solution in an easy fashion. We just apply the inverse linear differential operator. So this is 2e to the 2x. And that's it. End of solution. Parang it's a breath of fresh air, ano, compared dun sa mga pinagagawa natin last meetings. Okay? So are these two examples enough? Kasi may isa pang example dun sa handout, pero probably I think you can read it on your own. So we can proceed to the next case. Kasi ito nag-work lamang kapag yung f of k ay hindi equal kay 0. Question is, what will happen if f of k is not equal to 0? Definitely, we cannot apply this method. Even if you forgot that there are two cases, if you try to do that, or if you attempt to apply this, if f of k is equal to 0, you'll run into a problem. What problem? You'll run with division by 0. Okay? So, kapag ka 0, yung f of k, then we need to do a different approach. Okay? And for that, let's formalize it as case number 2. Or okay na ba na mag-case 2 tayo? Okay na yung dalawang examples for case 1? Nahalata na nagmamadali na ako, ano? So, but I think that's quite easy for you guys. All right, so let's look at the case when f of m is equal to 0. So if f of m is equal to, f of k, f of m kasi yung ginamit dun sa slides, it is quite confusing with because we used m para dun sa characteristic polynomial. Tapos ang ginamit niya nga palang notation sa f inverse of d, ang ginamit niyang notation ay 1 over f of d. And I like it better kapag ka siya ay naka-inverse function form at hindi reciprocal form. Kasi the reciprocal can be misinterpreted. Ano? So I prefer using f inverse of d rather than 1 over f of d. Okay, so I hope that's okay. So I suggest you stick to this, but I won't fault you if you follow the slides kasi hindi ko na i-upload itong scratch annotations ko, ano? Kasi pagkakalat nyo na pangit yung sulat ko. So, yeah. Ganun na lang. So, yung slides na lang, doon na lang kayo mag-refer. Okay. Now, the second case is what happens when f of k is equal to 0? Well, the factor theorem from algebra tells us that if f of k is equal to 0, that means that m minus k is a factor of f of m, right? Factor theorem mula sa algebra. Kapag halimbawa kapag si 0 ay isang root ng polynomial p, then x minus 0, which is x, must be a factor of the polynomial p. Right? That's the idea behind this. And if you translate this back into an operator form, then you can say that d minus k is a factor of f of d. Right? So yan yung makukuha nating implications mula sa pagiging 0 ni f of k. Right? Now, pero meron pa tong kakibat na iba pang mga notions because if f of k is equal to 0, we're sure that it is a root. But we don't know kung ano yung multiplicity ng root na yon. But luckily, this case doesn't care kung ano man yung multiplicity ni k or ni k as a root of f. So now we'll suppose a generic case So let's suppose k is a root of f of multiplicity n. Kung siya ay root of multiplicity n, ibig sabihin, d minus k raised to the n is a factor of f of d, right? Kasi multiplicity n siya, so n times siya nagiging root. So si d minus k ay n times magiging factor ni f of d. So this implies that f of d can be written as some function phi of d times d minus k to the n, where phi of k is not equal to 0. So ano itong mga crazy looking symbols na dinagdag ko rito? Sinabi natin kanina si f of d ay factor niya si d minus k over n. So ibig sabihin si f of d ay kaya kong isulat as d minus k raised to the n times another function phi of d. Hindi natin alam yung itsura ni phi of d. Basta pag finactor out mo, si d minus k raised to the n mula kay f, ang matitira ay phi of d. But we know one thing about phi of d. Phi of d will not become 0 when I replace d by k. Kasi si k, root lang siya of multiplicity n. Lahat na ng d minus k, nilagay ko na dun sa factor na to. So, ibig sabihin, wala na dapat ditong d minus k. Kasi kapag may d minus k pa rito sa factored form ni phi, ibig sabihin, magiging multiplicity n plus 1 na root si k. So essentially, I have factored out all possible d minus k's out of phi. So essentially, si phi of k ay hindi na pwedeng mag-0. Kasi anong implication pag nag-0 to? Ibig sabihin, pag nag-0 to, si d minus k is a factor of phi. Okay? Kung factor siya ni phi, pwede ko siyang i-factor out, tas magiging n plus 1 to, magiging multiplicity n plus 1 na si k as a root. So hindi yun pwede. Okay? Do you follow, guys? That fine? I hope it is. Okay. Then, dito na tayo mag-work. Maybe we can, it's a good point to recall theorem. Ano ang theorem yun? Tingnan ko sa kodigo ko. 3.4.4. Okay. Sana pala yung section 3.4 nilipat ko na lang dito sa section 3.7 para mas tanda pa natin or mas fresh pa sa atin yung mga theorems na yon. So from theorem 3.4.4, we noted there that d minus k raised to the n applied to e to the kx ay equal kay applied to e to the kxy ay equal kay e to the mx d to the n applied to y. So parang ito yung parang shifting. Ito nga ba yung exponential shifting? Or a specific case of exponential shifting, right? So kapag meron kang d minus k to the n applied to e to the kx times y, it is equal to e to the mx times the nth derivative ni y. Okay? Pero merong specific case na masaya rito. So just if y is x to the n, then d to the n, we can easily compute d to the n. D to the n will simply be, or applied to y, will simply be the nth derivative of x to the n, but that will just be n factorial. Tama? So kung papalitan ko ngayon, So papalitan ko ngayon yung y dito ng x to the n. So we'll have d minus k. Makikita nyo mamaya kung bakit gusto ko yung x to the n yung gawing y. And what would be its implications to our solution. So this would be, kapag ka nag-apply ka ng d minus k applied to n, sa e to the kx times x to the n ito ay equals sa e to the mx, d to the n, x to the n by theorem 3.4.4. But by our remark just now, this is equal to e to the mx times n factorial. Okay, and then we can apply the operator phi of d to both sides of the equation that we have just now. So I'll apply phi of d yun sa d minus k to the n applied kay e to the kx times x to the n. So ito yung magiging phi of d applied kay e to the mx times n factorial. And then dahil si n factorial ay constant, lalabas siya kay phi. So we'll have n factorial phi of d applied to e to the mx. Okay? But what do you notice here? Well, tingnan niyo yung left-hand side. Sa left-hand side, meron kang phi of d followed by d minus k to the n. So essentially, this guy is our f of d, right? So let me just write that down. F of d applied to e to the kx times x to the n ay equal kay n factorial phi applied to d e to the mx. Okay? And then now I can apply f inverse of d to both sides. So mag-apply ako dito ng f inverse d. Mag-apply ako dito ng f inverse d. We'll get what? Sa kaliwa, I'll have this canceled by that. So we'll be left with e to the kx times x to the n. This will remain in here. So let's just write it down. There's going to be e to the kx times x to the n equals f inverse of d applied to n factorial phi of d e to the mx. But n factorial is a constant, so it can come out of the inverse operator. So we'll have n factorial f inverse of d applied to phi of d e to the mx. Okay, is everything good so far? Or nakakahilo na, ang dami ng derivation, ano? So tinitrain ko kayo kasi baka may theoretical question na naman sa pre-finals para alam niyo yung gagawin, ano? So what do we notice here? How can I further simplify this to get rid of phi? Because I want a formula for f inverse. Kasi if flip ko mamaya yung equation. But the thing preventing me from doing that is I still have a phi of d over here. I want it to be eliminated. So what do we know about phi of d? Well, f is a polynomial by our assumption. So phi must be a polynomial. Kasi kung polynomial to, tapos ito ay polynomial, eh yung product daw ay polynomial, so dapat ito ay polynomial din. It's a polynomial where phi of k doesn't equal 0. Okay? Dahil si phi of k ay hindi equal kay 0, pwede kong i-apply yung case number 1 kay phi of k. So essentially, ito, pwede ko pala itong evaluate using pwede na, hold on. Hindi ko pa pala siya pwedeng gamitin. Sorry, I thought I can use case number 1. Pero let's think. What's another? How can I evaluate this? Oh, I think we have a theorem from. Oh, I think it's theorem 3.4.3. Tama ba? Tingnan ko nga yan. Sinulat ba natin yung kanina? Okay, there we go. Kapag ka meron kang f, imagine niyo lang si f ay phi. So kung may phi of d ka dyan, apply to e to the kx equal to kay e to the kx phi of k. And then i-divide natin both sides. Oh, do I need to divide both sides? Actually, I don't, right? So parang ano lang, lumalabas lang to doon, tapos in-evaluate mo lang si phi kay number k. Yan yung property ng exponentials from theorem 3.4.3. So I can apply that here. So I have n factorial f inverse of d. Then this guy, the one in yellow, can be evaluated using theorem 3.4.3. So it will be e to the mx, or but e to the mx, sorry, e to the kx to dapat. K, yeah, sorry, e to the kx to dapat. All right, just, yeah. So we don't confuse it with the indeterminate in the characteristic polynomial. So this is e to the kx, e to the kx times phi of k, right? Yan yung sabi ng theorem 3.4.3. Okay. And then what is phi of k? Phi of k is a constant, so it can come out of the inverse operator. So matitira lang sa loob ng inverse operator f inverse of d ay si e to the kx kasi siya lang yung may k, siya lang yung may x. Lahat ay constant na. So this is n factorial phi of k f inverse of d applied to e to the kx. And then I'll just copy the left-hand side over here. Okay? And then now I can divide both sides by this guy para ma-isolate ito sa right side. Then I'll flip the equation. So we'll have f inverse of d ay equal kay e to the kx times x to the n over n factorial p of k. This is f of d applied to e to the kx. And I hope you understand why I want this to be on the left-hand side. Kasi sabi natin, meron tayong f of d, y sub p equals e to the kx. Ang forcing term natin ay exponential. Gusto nating mag-apply ng f inverse d to both sides. So that will give us y sub p equals f inverse d e to the kx. And if k is a root of the characteristic polynomial f, so ang papampalit natin ay itong case number 2. Itong f inverse d of e to the k is equal to e to the kx times x to the n over n factorial times phi of k. I know that's quite a mouthful, so medyo maraming kailangang sauluhin para dun sa case number 2. Okay? So for this to make sense, maybe let's look at particular examples. Just interrupt me if you have questions. Napatingin na naman ako dun sa oras. So kailangan ko na naman mag double times examples. But I hope the derivation at least makes sense. And then you can read back and see kung ano nga ba yung nangyari if there's something not clear. Pero it's usually easy to complement the theoretical derivation by a tangible one muna. Para ma-appreciate yung process, tapos mamaya pwede nyo balikan yung theoretical derivation na, okay, ganito nga pala to nangyari. Kaya pala ganito yung gustong pagkakasulat ng final answer sa case number 2. Okay? So, tangible example first. So let's solve the following GLDE. D squared, d minus 1 cubed, d plus 1, all applied to y equals e to the x. Ang forcing term natin ay e to the x. So that means here we have k equals 1. Right? But in any case, since we are looking for the general solution, we start with the particular solution. Right? We start at the homogeneous solution. So here we or before that, let's set our notation straight. So let's let f of d to be equal to d squared times d minus 1 cubed times d plus 1. Then f of 1, which is our f of k, f of the coefficient to x in the exponent of e, is obviously equal to 0. Kasi pag nag-plug in ako dito ng 1, ma-cancel na rin siya. Right? And moreover, 1 is a root of f of multiplicity 3. Kasi try siyang magiging, kasi yung yung m minus 1 o yung d minus 1 ay thrice naging root nung f of d. Or yung d minus 1 ay thrice naging factor ng f of d. Right? So that means here our n is equal to 3. Multiplicity 3 kasi siya. Okay? So hindi gagaya sa case number 1, so pupunta tayo kay case number 2. But before we go there, let's compute for the particular solution. For the homogeneous solution. So note that the roots of f are what? The roots of f are 0 of multiplicity 2, 1 of multiplicity 3, and -1 of multiplicity 1. Hence, the general solution will look like this. Review the form for the homogeneous solution. Meron kang solution 0, multiplicity 2, so dapat meron kang linear multiplier, C1 plus C2x, supposedly e to the 0x, but e to the 0x is just 1, so wag ko na yung isulat, plus C1 ay multiplicity 3, so dapat meron siyang quadratic factor, C3 plus C4x plus C5x squared, times, ang root ay 1, so meron tayong e to the 1x. There you go. And then si -1, thankfully, ay multiplicity 1 lamang, so meron lang ako ditong C6 times e to the -x. Then let me just copy this for later. Okay, so sana tandaan niyo pa yung pagkuha ng homogeneous solution. Now, the supposedly hard part, which will turn out to be easier than the homogeneous solution in this case, ay yung pagkuha ng particular case. So we want a particular solution. So we want to find y sub b such that f of d applied to y sub b equals e to the x. But again, we knew that f of 1 is equal to 0. And not just that, it's 1 is a root of multiplicity 3. Okay? So gagamitin natin yung case number 2 with k equals 1 and n equals 3. So that means y sub b is equal to f inverse of d times e to the x. But this guy, f inverse d of e to the x, is just e to the x times x to the multiplicity, right? And multiplicity 3 siya, so x cubed all over n factorial, which is 3 factorial, times phi of 1, right? Galing dito sa formula na ito. So e to the 1x times x to the 3 all over 3 factorial times phi of 1. Pero ano nga si phi? Si phi ay yung natitirang factor kay f na hindi kasali si d minus 1. Right? So here, siguro dapat pala sinulat ko yun dito. So here, this will also imply that phi of d ay equal kay d squared, d plus 1. Right? Kasi kailangan nating tanggalin mula kay phi yung d minus 1 cube. Kasi siya yung d minus k to the n. Right? Siya yung factor na wala nang kinocontain na d minus 1. Kasi gusto natin ang phi of 1 ay hindi mag-equal kay 0. And that is now guaranteed because we took away all of those factors that can possibly make phi of d equal to 0. Nandito siya sa d minus 3 cubed. So ibig sabihin, ito ay d squared times d plus 1. So this would be e to the x times x cubed over 3 factorial times, ano nga siya, d squared times d plus 1 times d plus 1. So I'll have 2 squared there. Okay, then you simplify this, you're going to get e to the x times x cubed over 6 times 1 squared times 2 squared. So it's going to be 4. Sorry, that's going to be, tama ba? 4. Ano nga yung phi? Ang phi ay ito. Plug in ko si 1. Ito ay 1. 1 times 2 lang pala. Sorry. But may squared. 1 times 2 lang. So this would be times 2 So it's e to the x cubed over 12. Yeah, thank you, Kiefer. D plus 1 nga lang siya. So d squared times d plus 1. All right, so therefore, at least alam ko nakikinig pa si Kiefer. Usually, palusot ko yan sa klase pag may mga ganong bubu akong nagawa. So, sabihin ko, tinetest ko lang kung nandyan pa kayo, kung nakikinig pa kayo. So finally, the general solution is y equals our y sub c, which I copied over from above, plus the particular solution, e to the x cubed all over 12. Okay, all good? Sige, one more example pa para mag-stick yung method. I think we're an example 4 now. Example 4 natin ay siguro d squared times d minus 2 to the fourth times d minus 1 y applied equals e to the 2x. Okay, so in this particular case, we'll get k equals 2. Siya yung exponent ni e. So let's try. So we will let f of d to be equal to d squared times d minus 2 to the fourth times d minus 1. And this will imply that f of k, or which is f of 2, will be equal to 0 for sure, because you have a d minus 2 here. You plug in d equals 2, you get 0 as a factor, so everything goes to 0. And moreover, 2 is a root of multiplicity 4. Kasi apat na beses naging factor si d minus 2. Okay? And this will also tell us also that phi of d consists of the product of the remaining factors. So this is d squared times d minus 1. Tinanggal ko yung apat na d minus 2s dun sa factor. So that f of d, this entire f of d is equal to phi times d minus 2 to the k. Right? So first bullet, medyo shortcut ko na. But in your solutions, you need to include all the details and all the explanations. So sketch na lang to ng solution. So kindly fill out the missing details. Now, because I can find y sub c by inspection, but I want you guys to write it, especially if it's a take-home exam, para alam ko na alam niyo yung ginagawa nyo. Siguro pag sit-in exam, mas lenient ako dun sa hindi sinusulat lahat ng steps ng solution or explanations, because I know you're there and you're doing it on your own. So problema ko lang kapag ka take home, I want you to explain all of the steps. So here we know that d squared, so that means that will give me 0 as a root of multiplicity 2. So I'll have c1 plus c2x plus, or supposedly times e to the 0x. Then we have d minus 2 raised to the fourth. So e to the 2x will come up with a cubic factor. C3 plus C4x plus C5x squared plus C6x cubed. And then d minus 1 is once a factor. So we'll have a plus e to the x over here. So this is our times c sub 7. This is our general, this is the general solution to the homogeneous version. Let me copy this over. Okay. Now the problem is to find y sub p. But we want to find y sub p such that f of d applied to y sub p I equal kay e to the 2x. But then again, if I apply f inverse of d to both sides, I'm going to get y sub p equals f inverse of d applied to e to the 2x. But by case number 2, we already knew that f of 2 will be equal to 0. So alam ko na hindi gagana si case number 1. So I'll directly appeal to case number 2. It tells us it's going to be e to the 2x times x to the multiplicity of the root. So our 2 is our k, which is 2, is a root of multiplicity 4. So get an x to the fourth there, all over 4 factorial times phi of 4. Ano nga ang 4 factorial? Ang 4 factorial ay 24 times phi of 4. Ito si phi. So I have 4, 4 there. So it's going to be 16 times 3. Tama ba? Parang may mali. Parang hindi yan yung nakuha ko kanina yung sinasolve ko to. Phi of 4. Sorry, but phi of 4? Phi of 2 nga pala yung sinasolve ko, right? It's phi of k. Phi of k yung pina-plug in ko dito sa denominator. Lagi kong kinokopya yung exponent. Kasi nag-n factorial ako dito. Akala ko phi of n din yun. That's phi of k, right? Phi of k siya dapat. So that means k is equal to 2. So I'll get 2 there. So that's going to be 4 times 1. So there would be a 4 below. Yan, mukhang familiar na yung numbers. Over 96. So therefore, the general solution y is equal to the particular solution plus, the homogeneous solution plus the particular solution we just found out right now. End of solution. That easy. Okay? Questions? Kaya ba mag-homework for this one? Walang sumasagot? Sige, magbibigay ako ng homework. Hold on. Actually, may naka-ready na akong homework eh. Kunin ko lang sa messenger ko. Na yung messenger ko. Oops. Para practice na rin. Huh. Sorry, dapat pala mamaya pa to. Kasi parang yung case number 2 pa lang yung number 2 pa lang yung papasok dun sa mga diniscuss natin ngayon, ano. Meron pa kasing sine and cosine, but that will involve 2 more theorems that I will share with you. 2 or 3 more theorems that I'm going to share with you. Apat pa pala yung theorems, ano. Kakayanin ba natin in 10 minutes? Let's try, ano. So let me just cut this. So yeah, mamaya ko na lang ulit siya ibibigay. Okay? Any questions kapag ka si R of x ay exponential? I think we have now a good and short approach kapag ka si R of x ay exponential of the form e to the kx. Okay? Now, another special R of x that can easily be solved using inverse linear operators ay yung mga trigonometric. I mean, trigonometric in terms of sines and cosines. So let's do that here. So section B would be when R of x is equal to sine of AX or sine of BX, yung ginagamit ko na to na notation, or R of x is equal to cosine times some constant times x, cosine BX. All right? So kapag ganito naman yung case, yung right-hand side ng non-homogeneous GLD ay sine of BX or cosine of BX, meron tayong 4 na theorems na posibleng gamitin. So let's start with the first theorem, 3.7.1, yung pangalan niya dun sa handouts. So let's consider, specific nga pala tong mga to, no? Specific ngayon si D. si f of d as d squared plus a squared. So let a be a positive constant. So not really positive. A can be any real number. Then and f of d equals d squared plus a squared. Okay, so halimbawa yan yung case. Ang ating operator ay d squared plus a squared where a is a real number. Then if a is not equal to b, meaning this a here is not equal to the b there, then we can easily compute f inverse of d applied to sine bx. When applied to sine bx, ang f inverse of d lamang ay sine ng bx all over a squared minus b squared. And you see how important here, how important that a is not equal to b. Because if a is equal to b, then this denominator doesn't make sense because it's going to be 0. Okay? And similarly, f inverse of d applied to, I think, sa cosine, ay kamukha rin niya yung result. Applied to cosine bx ay equal naman kay cosine bx. Nilagyan lang siya ng denominator na a squared minus b squared. So here are two formulas that you need to remember. So kaway-kaway dyan sa mga ayaw din na nagsasaulo because personally, I also hate memorization. Kung talagang bawal yung cheat sheet sa exam, ginagawa ko, diniderive ko to. Hinahanapan ko siya ng theoretical, nag-isip ako ng paraan para, or memory, kung saan ma-attach ko itong formulas na ito. No? So ganun yung ginagawa ko. And I think one easy way to remember this is to think of the proof. Medyo weird. Kaysa magsaulo, magpo-prove pa ako, no? Pero anyway, so some people learn that way. Okay. So now let's try to prove this. Let's prove equation star. Nakapag-star na tayo kanina, no? So check na lang to. Tapos ito ay si equation double check. Okay. So I'll just do the proof of equation check. So equation check, ang sinasabi niya ang f inverse of d of sine x ay equal dito. So ibig sabihin, one way to prove this is to compute f of d of sine bx. Kasi ang sinasabi nito ay, kapag ka in-apply mo yung reverse process ni f kay sine bx, ito yung makukuha mo. Sine bx over a squared minus b squared. So to prove this, parang mag-apply ka ng f of d to both sides. Computein mo yung f of d kasi mas madali sa atin na computein si f of d kasi given na to. So i-apply mo si f of d kay sine bx over a squared minus b squared at ipakita mo na yung sagot ay sine bx. Yun yung idea dun sa proof. So that's one way to prove this. So we can do this by applying f of d dito sa right-hand side. Okay? So note that f of d applied to sine bx over a squared minus b squared is equal to d squared plus a squared applied to sine bx all over a squared minus b squared. Okay? So nakita nyo ngayon, mas madali talagang isolve. Kesa isolve ko to, hindi natin kayang isolve to kasi hindi natin alam explicitly ano yung itsura ni f inverse of d. Pero alam natin yung itsura ni f of d. Kaya ang pwede kong gawin, mag-apply ako, kumuha ako ng isang equivalent statement. Mag-apply ako dito ng f of d both sides. Okay? Ito ay maka-cancel. So kailangan ko lang ipakita ng f of d applied to sine bx over a squared minus b squared ay equal kay sine bx. Yun yung goal ko ngayon. Okay? Remember, a is a constant, b is a constant, d squared is the second derivative operator. So mangyayari lang dito ay magiging second derivative with respect to x ni sine bx over a squared minus b squared plus constant a squared times sine bx over a squared minus b squared. Okay? Tapos second derivative daw. So, computing ko muna yung first derivative. Tapos i-differentiate ko yung first derivative. First derivative nito, si a squared minus b squared ay constant lang naman. So, lalabas yan ng first derivative. Actually, pwede nyo nga siyang ilabas na nung buong derivative, right? Because this is a constant. Oops. You could have written it out of the differentiation process right away. Pero kinip ko na lang siya dito. Tapos derivative lang to ni sine bx. Derivative ni sine bx ay b cosine bx. Right? Kasi si b ay constant lang naman. And then I'll copy this over. Okay. Tapos kailangan ko pa ngayon mag-derivative. I-differentiate ko naman ito. But if I differentiate that, magkakaroon ako ng b over a squared minus b squared sa labas times derivative na lang ng cosine bx, but that's negative b sine bx plus this guy. Oops. Okay. Plus yan. Tapos, ito ay magiging negative b squared over a squared minus b squared. Uy, may sine bx. Pwede kong i-factor out si sine bx. So, kakaroon ng sine bx. Ang matitira rito ay positive a squared. Sorry. Lalabas ko rin pala yung a squared minus b squared. Kasi parehas din naman silang meron nun. Okay? So, matitira lang dito sa second term ay a squared. Matitira sa second term, nalabas ko na to, nalabas ko na to. So matitira na lang ay si minus b squared. Yay! A squared minus b squared. Makakancel ng a squared minus b squared doon. So I'll have sine bx. So ang sinasabi dito ay, pag in-apply ko si f of d kay sine bx over a squared minus b squared, makukuha ko si sine bx. So therefore, ang f inverse of d applied to sine bx ay equal doon sa ansatz natin kanina. Sine bx all over a squared minus b squared. End of proof. Okay? And I think you can prove the same thing para naman doon sa cosine. All right? Any questions? So yung proof ng double star is an exercise. So siguro isa or dalawang mabilis na examples if you permit me. If you need to go because you have a class, so you can. Kasi 11:20 na. Pero gusto ko sana makapagbigay ng dalawang examples. Then yung case ng ang a squared, ang a ay equal kay b, ay itatakal na lang natin sa Friday. Okay? Kasi rito ang assumption natin si a ay hindi equal kay b. Para yung a squared minus b squared ay hindi magsi-zero. Pero meron ding theorem kapag ka nag-zero ang a squared minus b squared. Yun, dun tayo magsisimula sa Tuesday, sa Friday. Okay? But you can read ahead if you want. Nandun naman siya dun sa slides. Pero siguro, let me give one or two examples involving this. Quick ones. But yeah, again, if you need to leave, please do so. Right? Enjoy the weekend na lang, guys. Pero if you have nothing good to do, so you can stay with me as I discuss these two examples. Let's see. Example 3, 4, example 5. So we have d squared plus 1 applied to y equals sine 2x. Ganito na lang pala. So siguro mag-extend na ako ng hanggang 11:45 para matapos ko lahat ng cases. Tapos papanoorin nyo na lang in case hindi nyo natapos yung klase today. Para makasave tayo ng time. Kasi konti na lang talaga yung susunod na, yung dalawang natitirang case. Kasi formulas lang din naman yung ibibigay ko. Hindi ko na siya i-prove. Magpapakita na lang ako ng examples. But before you leave me, just remember there's a homework. I will make it due on Friday next week, which will tackle the things that we discussed today. So watch out for the announcement in Canvas for that. Okay. Pero going back to example number 5. So here we have what? So here we have a equals 1, which is a squared ay equal kay 1. Kasi nga pala ang form ng ating operator dapat ay d squared plus a squared. Doon lang nag-work yung theorem na to, right? So dapat ang itsura ng operator mo ay d squared plus a squared. Take note of the value of a squared. So a squared is equal to 1 here. And then take note of the value of b. B is the coefficient inside the trigonometric function. And obviously, a squared minus b squared is not equal to 0. So the previous theorem will work. Okay? So madali lang pala siya. So tingnan muna natin. Kailangan ko muna yung homogeneous solution. So I'll just sketch the solution here. Pagkuha ng y sub c. Para sa pagkuha ng y sub c, d squared plus 1. Characteristic equation ay m squared plus 1 equal to 0. Roots niyan ay plus or minus I. Complex roots, magkakaroon ako ng y sub c na sines and cosines. So I will have c1 cosine x plus c2 sine x as the homogeneous solution. Now to find a particular solution, we want meron kang f of d applied to y sub p equal kay sine 2x. To get rid of f of d here and have y sub p isolated, I'll apply f inverse d to both sides. Ganito yung mangyayari. Pero may theorem na tayo kanina na kapag ka si f ay d squared plus a squared, tapos ang a squared ay hindi equal kay b squared, our a squared here is 1, our b is 2. So therefore, f inverse of sine 2x is simply sine 2x all over a squared minus b squared. So that's sine of 2x all over what? Negative 3? Tama ba? Negative 3? Okay, hopefully my arithmetic is still working. So therefore, ang general solution ay c1 cosine x plus c2 sine x minus sine 2x all over 3. End of solution. Parang ang dali bigla ng buhay natin, no? Parang itong mga huling linggo, ang hirap-hirap. Kasi bago natin makuha yung y sub p, ang daming nangyayari. Pero may mga formulas naman palang ganito para dun sa y sub p. Right? Another example. But feel free to interrupt me if something is not clear. Okay. In this example, I will just again sketch the solution. It's up to you to formalize everything. So here we have a squared is equal to 4 and b is equal to 3. A squared minus b squared will not be equal to 0, so the previous theorem will apply. So first, I need to have the what they call this, the homogeneous solution. The homogeneous solution will depend on the solution of the characteristic equation m squared plus 4 equals 0. The roots here would be solutions to m squared equals negative 4. So that means m equals plus or minus 2i, right? So that means our solutions would be c1 cosine 2x plus c2 sine 2x, right? And our particular solution can be found by applying f inverse of d to sine 3x. But our theorem tells us that this is sine 3x all over a squared minus b squared. So this would be sine then 3x over negative 5. So therefore, our general solution is c1 cosine 2x plus c2 sine 2x minus sine 3x all over 5. End of solution. Okay. Grabe, 1, 2, 3. 3 steps lang yung solution. Ano? Compare dun sa variation of parameters, undetermined coefficients, and the other methods that we discussed before. Okay. So kapag ka cosine, susundin nyo lang yung formula para kay cosine. So you will see in the handout, in the modules, na meron pang dalawang example akong binigay doon. Pero nabago lang naman cosine naman yung function sa right-hand side. But that's not a big issue because we have the theorem for those cases. Okay. Now, I will just enumerate yung natitirang theorem. Ginawa ko pala ron dun sa handout para lang consistent yung numbering. This is theorem 3.7.1 and 3.7.2. Magkahiwalay kasi yung numbering dun sa slides. Right? So dito ay theorem 3.7.3 na to dun sa handout. So kapag meron kang f of d equals d squared plus a squared, then ang f inverse of d applied to sine of ax ay equal kay negative x cosine ng ax all over 2a. Now, ito yung case na si a ay equal kay b. Kaya dito ay, ito ay yung a naging b na. Kasi ang mangyayari doon, magkakaroon ka ng a squared minus a squared, magzi-zero yung denominator, makikita mo right away na hindi mag-apply yung theorem 3.2 nor theorem 3.7.1 and 3.7.2. So ito yung gagamitin natin. And the proof can be written similarly to what I did before. Kunin nyo lang yung d squared plus a squared applied to this, and you will be able to show after simplification that that will be sine of ax. So paki-double check na lang. And then theorem 3.7.4 is quite similar to this. Same assumption, pero ngayon naman, ang isa-subject ko sa f inverse of d ay si cosine ni ax. Kapag cosine yung function na involved, siya naman ay positive x sine of ax all over 2a. Ito, hindi ko na ito kayang tandaan. So, hopefully, you can remember this at least kung face-to-face yung exam. Pero ako, mahirapan ako magsaulo niyan. Gawin ko yan, sasauluhin ko yan habang nakaupo na ako dun sa exam room kasi ang iksi ng memory ko. So, hindi ko to kayang sauluhin talaga. Okay. So, a couple of examples, probably one kasi time na. You can read the other examples in the module. So, let's try example, what? 1, 2, 3, 4, 5. Example 6 na ba to? I hope so. I will have d squared plus 4y equals cosine 2x. So here, you will note that a squared is equal to 4. That's what we have here. Tapos yung b ay 2, which is the coefficient inside cosine. But this will give us a squared minus b squared equal to 0. So you cannot use neither equation, theorem 3.7.1 nor 3.7.2. So kailangan yung gamitin itong formula na ito. Okay. So, unahin ko yung pagkuha ng particular solution. So, sketch lang naman ako ng solution eh. Pero kayo, bawal na sketch lang. Dapat full solution. Now, I will find y sub b. So, fd y sub b. Gusto kong maging cosine 2x. So, y sub b then will be f inverse d applied to cosine 2x. So, for this theorem, a is equal to 2. I will apply that here. So I'll have x sine of 2x all over 4. That's the particular solution. And then the general solution, the homogeneous solution will be based on the solutions to m squared plus 4. Oh, ito lang pala yung kanina nating sinolve na homogeneous system, no? Or homogeneous equation. So this is c1 cosine 2x plus c2 sine 2x. Tapos, syempre, yung general solution, y, ay equals sa homogeneous solution plus the particular solution. And there you go. Halos 1 minute lang yung solution. Kung ginamit natin yung undetermined coefficients, abutin tayo rito ng mga 10 minutes or 15 minutes pag ako'y nagdi-discuss. Okay? Now, there are two more There are two more examples in the module, so kindly check them out. But I want you to try to answer the following. Pwera yung number 1. Wag na yung number 1. So choose one. I think this is homework 12. Choose one lang from 2, 3, and 4. Kailan ang gusto niyong deadline? May deadline ba kayo next week sa 151? Hindi ko na itatanong kung may deadline kayo sa ibang subject kasi malamang meron. Meron ba tayong homework due next week? Meron, December 1. I remember kasi holiday November 30. So, December 2. Kaya ba ito ng December 2? Isasabay natin or next week na lang? Ano gusto nyo? Kailan nyo gusto itong maging due? Next week, Wednesday, week after next na lamang para hindi sabay-sabay. Pero again, if you can submit it early, the better para matanggal nyo na siya sa inyong mga plato. Ano? Kasi alam ko marami kayong ginagawa. So let's make it due on December 7. Right before midnight. Okay? I'll post the homework later in Canvas para maalala nyo at nasa Canvas calendar nyo yung deadline. And I'll stop here. Sorry, overtime ng 2 minutes or actually 12 minutes. So any questions? Medyo binilisan ko ngayon kasi parang ano lang naman, mechanical yung topic ngayon, ano. Pero ang laking bagay nung itinulong sa atin nitong method na to. But unfortunately, napaka ad hoc or napaka targeted ng mga functions kung saan magwo-work itong dalawang methods or itong dalawang sections na diniscuss natin for today. The first case is a little bit more generic because the first case ay e to the kx tapos kahit anong function kahit anong polynomial si little f. Pero itong pangalawang section, dapat sine ax o kaya dapat sine bx or cosine bx yung r. Tapos yung operator f dapat d squared plus a squared lang siya palagi. So be careful. Don't be tempted to use these methods kapag hindi siya nag-apply. Napaka-targeted netong dalawa na ito. Okay? So any questions or concerns? So if there are none, thank you guys for joining me today. I hope you'll have a wonderful weekend. One of the few weekends before Hell Week ito siguro. So try to enjoy it and let's see each other again on Friday. Okay? Bye guys. May meeting nga pala ako.